Hey everyone, and welcome to this video. In this video, I'll be showcasing you two coolest features in my opinion of the version 3.0, and that is the ABI to C# contract converter, as well as subscribing to the events that are happening on the blockchain. Okay, here we are in Remix IDE, and in here we have the basic counter contract that has one value, count, that we are incrementing in the function increment. Now, we are not returning the count value as a return value simply because outside of the EVMs, we are not getting the method return value at all. So there are two options. First one is the one that we're doing here, and that is to emit the count changed event. And the second one would be probably to create some sort of a get count function that will be public, and it will return the uint 256, and we will just return the count. I will now deploy the contract, and I'm using Optimism's Sepolia. I will go to the block explorer, copy paste the contract address, and let me go to Solidity compiler and copy the ABI to clipboard. Now let me go back into Unity, and in Unity, Web3.Unity test is basically empty. It only has this initialization in here. So let's see how actually we would create the call to the blockchain without the proper ABI to C# contract converter. Obviously, we need the contract address and we also need the ABI. Let's store the reference to the contract, and in the Web3.Unity and Web3 initialized, let's build the contract. And we're going to build it by calling obj.web3.contractbuilder.build, and we'll pass in the ABI and the contract address. And now comes the ugly part. First thing, you need to come here to contract and type in call or send, because maybe you don't know, is it a read or a write call to the blockchain? Because for send, you're writing the thing to the blockchain, but for call, you're just reading the data from the blockchain. Then comes the second part, and that is that you have to memorize all the methods from the entire ABI yourself. I mean, we can technically call here increment, and we can inspect the ABI itself for the proper name of the method. And then the last thing is that you need to pass in the parameters, and you might get the type wrong. So for example, previously in our SDK we had an issue with ERC1155 where we were passing in the big integer where the contract expected a hex big integer. So currently for the increment method we don't have to do anything. We just need to pass in the empty array of parameters. We can await it here. And of course, we don't have the subscription to blockchain events supported for this regular old contract. But if you want, you can probably do something like this: public class count changed DTO event, and it needs to inherit from the I event DTO. It needs to have an attribute of type event count changed, and then it needs to have a parameter uint 256 new count 0, and then if it's indexed, is it true or false? I know that in my case it's false, and then I'll type in public big integer new count get set. And with this you can technically subscribe to the blockchain event through our event manager, but I will show you how you can do it with our ABI to C# contract converter right now. So now let's go into assets scripts and create a new folder called custom contracts. Let's go to ChainSafe SDK and let's open up the contract ABI to C# converter. In here we need to put three things, and that is the contract name, let's call it counter. For the folder, let's set the custom contracts folder. And lastly, let's paste the ABI that we got from our Remix IDE. And as you can see, we have this ABI pasted. Let's click on convert, and after a couple of seconds, the contract counter has been generated. Now let's get back into our Web3.Unity test. Let's create a new serialized field, string contract address, and let's create a variable of type counter that is part of the ChainSafe Gaming EVM contracts custom. And inside of the Web3.Unity on Web3 initialized, let's assign the counter to be equal to the following: obj.web3.contractbuilder.build, and for the generic type, let's pass in the counter, and also let's pass in the contract address. Now since this returns a task, let's await it. And you should always build your custom contracts inside of the Web3 initialized event handler, because sometimes the references can be lost if you're doing it inside of the awake or start or anywhere else. So I'm highly recommending you to do it only in the Web3 initialized event handler. And let's see what we have here. here we have the counter.onCountChanged event. As you can see, it looks identical to all the other C# events because we did the hard lifting behind the scenes so that you as a developer can just easily subscribe to this event like you would to any other. So let's subscribe to the onCountChanged and let's type in countChanged here, and let's type in here debug log countChanged plus obj.newCount. Now, because previous Web3 instance might be lingering in memory, what I also like to do is the following. I like to create a method that says cleanup custom contract, and then I will type in the following. If counter is not equal to null, I would like to call the dispose async, but before disposing it, I want to call counter on counter changed minus equals count changed so that everything is properly cleaned up and that we don't have any memory leaks. Let's make this method async. Let's await the dispose async. And yeah, let's do the exact same thing in the onDestroy. Perfect. Now there is one more thing that we need to do, and that is to go to Web3.Unity and we need to add the event service adapter, because event service adapter is actually responsible for adding the ability to read the events from the blockchain. Otherwise, that functionality will not be available to you. Now let's go to ChainSafe SDK project settings, and let's see, here we have the OP Sepolia testnet, and we want to make it the default one so that we can read the event and also so that we can call the increment function from that specific network. So let's remove Sepolia for now, and that means that OP Sepolia testnet is the main one. And since Sepolia already has webhook, we don't need to set this force event polling to on. That should be done only if your blockchain provider doesn't have a WebSocket URL. Now let's paste in the contract address from the deployed contract, and also let's get back into our IDE, and below the counter assignment, let's call the increment function. Let's await it as well. Let's call here debug.log increment called. Let's go back into Unity. Let's click on play, and I will connect with my wallet connect, and I got the count changed to 2, but actually I had to tick this force event polling because Sepolia's webhook didn't properly work. So what I would advise you to actually create your own webhook for the blockchain that you want to be on, so that you don't depend on some public services that oftentimes cannot provide fast enough response. So I ticked this, and I also got the count changed to 2 event response. So that is nice.